probability density function. So before starting with PDF, let me just recall what we have studied in the previous session about CDF. CDF, cumulative distribution function. So in the previous session we have studied that the CDF value at any point x represent the sum of the probability at that point x and all the points less than x. We also seen that the formula to calculate CDF, that is sum of probabilities less than or equal to x, is equal to integration of minus infinity to x of probabilities or probability function, which I have told you we are going to get from the PDF table. Now in this session we will upgrade our formula to the usable form which you will use in your exams, and we will see that the CDF value, that is probability x less than or equal to x, is equal to integration of minus infinity to x of PDF. Here this is the symbol of PDF, where this capital X is a random variable and this small x is a real number values. Now let us start with the PDF. Like we have discussed in the session 2 about PMF, that PMF are used to represent the probabilities for discrete random variable. Similarly, PDF are used for continuous random variable. Now PDF represents probability of happening of an event when x takes value x. Here this capital X is a random variable and this small x represent the real number values. And as I have told you, in PDF case this is for continuous random variables. It is represented by the symbol small f, capital X, and here small x. This is the symbol for PDF. And in the previous session of CDF we have seen that the capital F was a symbol of CDF. Don't confuse in these symbols. So now let me take an example to explain you how the PDF is used for the continuous random variable. Now this is the example of PDF. Now you must note that in the CDF we have studied that at any point x we get the sum of the probabilities at x and for the points less than x. But in the PDF table at any particular point we get the probability when the x takes that value. It is quite similar to the PMF. The only difference is that here the x varies in the continuous range. That is, like in this example, the range is 0 to 1. So since this is a PDF, so x can take all real number values between 0 and 1 that you can think, including 0, since here is a equal to sign. So x can take any real number values that you can think between this range. And if this would be the PMF, then X can take only some discrete and countable finite values. But since this is a PDF and PDF is used for the continuous random variable, so this X varies in the continuous range. So if I will draw the graph for this PDF, then it would be like this. Here we will be having 1, and here we have the 0. So at 0 the PDF value was equal to 1, and till 1, for all the real number values between 0 to 1, the PDF value remains 1. So the graph would be like this, and at 1 again the values comes out to be 0, and for all other points it remains to be 0. So this would be the graph. For negative points also the value will be 0. Now, as I have told you, PDF represents the probabilities of happening of the event when X takes a particular value X. So, if from PDF table you take any value, like if you take 0.5, X is equal to 0.5, and takes the PDF value which is 1, then you will get that Fx 1 is equal to 1. Then it means that the probability that X takes value 0.5 is equal to 1. So from this example you can clear your concepts of PDF. Now an important property of PDF which links the PDF with the CDF is that the PDF is equal to derivative of the CDF. This is the most important property of PDF which links the PDF with the CDF. Now we will study the properties of PDF. Properties of PDF. Now the first property of PDF says that the PDF value at any point is greater than or equal to 0. Now this can be understood in the two ways. The first way to understand this is that, as I've told you, this is the PDF value, and the PDF value represents the probability of happening of the event at the particular time when the capital X takes value small x. So since this is the probability can't be negative, or you can understand it by linking with the property of CDF. We know that, as we have studied in the previous session of CDF, that CDFs are non-decreasing functions, and derivative of non-decreasing function is always greater than or equal to 0. Now to understand this, you must know the fact that derivative of increasing functions is greater than or equal to 0, and derivative of decreasing function is less than or equal to 0. So this can be understood with this fact, or with this property of derivative of increasing function. Now the second property of PDF is that the CDF CDF value at any point x is equal to integration of minus infinity to x that is integration of minus infinity to x of PDF value. This can be understood with this property. Since the PDF was the derivative of CDF, the CDF is integration of the PDF. Now the third property of PDF is that minus infinity to infinity integration of PDF is equal to 1. Now this is true for all the PDFs. Now again, if you will recall some properties of definite integral, which is minus a to a integration of any function is equal to twice of integration of 0 to a if this is an even function and 0 if fx is an odd function. So if you will recall this property of definite integral and use this property in this case, then you can get the result that since minus infinity to infinity integration of PDF is equal to 1, it can't be 0 at all. Therefore, the CDF, the PDF can't be odd function. And if in case the PDF is an even function, then 0 to infinity integration of PDF multiplied by 2 is equal to 1. And third, in the third case, the PDF can be neither odd nor even function. So this is also possible that the PDF that you have is neither odd nor even function. So both of these will be excluded in this case. Now let us move on to the fourth property of PDF. The fourth property of PDF says that if A and B are constants, then probability that the random variable lies between A and B is equal to CDF value at B minus CDF value at A. Or in the PDF term, I can say that probability that the random variable lies between A and B is equal to integration of A to B of PDF value. So now let us practice some example to understand all these properties. Now this is the first question. It is given to us that random variable y has the following CDF. Given to us that when y is less than 0, then the CDF value will be 0, and when y lies between 0 to 1, the CDF value is y cube, and for y greater than 1, the CDF value is 1. And here we need to find the PDF of capital random variable y. So let us do the A part. Now using the property that the PDF is derivative of CDF, here I will use the same random variable for both of these. So I need to make x as y since y is the random variable here. So again rewriting this property as clearly, I will be having PDF as derivative of CDF. So this is the property that you are going to use in this A part. Now the CDF is equal to Derivative of 0 will be 0. Derivative of y cube will be 3y square. Derivative of 1 will be 0. Now this is the PDF of the random variable y, and this is very simple to calculate. Now it can be rewritten as 3y square in the range 0 to y less than equal to 1 and 0 otherwise. So this is another way, or I can say the more prevalent way to write the PDF. Now let us move on to the B part. Now here they have asked us the probability that the random variable y lies between 1 by 4 and 3 by 4. So as we have seen in the fourth property of PDF, we have two ways to calculate this. The first way to calculate this is 1 by 4 using the CDF that we have. That is the CDF value at 3 by 4 minus the CDF value at 1 by 4. So if I will calculate this, then the CDF value at 3 by 4 is 3 by 4 cube. Now why 3 by 4 cube is? The reason is that the 3 by 4 lies in the range 0 to 1 and the CDF value for this range is y cube, and here the value of y is 3 by 4, so it is 3 by 4 cube. Similarly, the CDF value at 1 by 4 will be 1 by 4 cube. Now solving this, we are going to get 3 cube, which is 27, minus 1 upon 4 cube, which is 64, which is 26 by 64 equal to 13 by 32. Or the another way to calculate this is using this PDF. The probability that the random variable y lies between 1 by 4 and 3 by 4 is integration of the PDF values from 1 by 4 to 3 by 4. Now for the range 1 by 4 to 3 by 4, the PDF value is 3y square, so we will integrate this. 3y square, 1 by 4 and 3 by 4. So solving this integral, this definite integral, we are going to get 3y cube upon 3, 3 by 4, 1 by 4, and again we are going to get, on putting values, 3 by 4 cube minus 1 by 4 cube, which will be again equal to 13 by 32. Now these are the two ways to calculate this part. And from this part, the fourth property of PDF is clear to us. So now, as I've told you in the previous session of CDF, that we will understand this property of CDF, which is CDF is equal to integration of minus infinity to x of PDF. Now we can understand this property from this example itself. Now the PDF that we have got in this example is this. It is 0 for all other cases and 3y square for the range 0 to y. Now if we want to get the CDF from this PDF again, then we need to use this property. Now to get CDF from PDF, you first need to draw the number line and mark the different points on the number line which you are able to see in the PDF. Here the different points that I am able to see are 0 and 1. It's 0 and 1. The only different points that are visible to me in the range are 0 to 1. So I have marked that points on the number line. Now as you can see that these points divide this number line in three different regions. The first one is from minus infinity to 0, the second one is from 0 to 1, and the third one is from 1 to infinity. So you will have three different ranges for CDF as you have seen in the CDF of y. At CDF in this range, you need to integrate the PDF in this range. CDF in range minus infinity to 0 is equal to integration of minus infinity to 0 of PDF. Now we know that in this range the PDF value is 0. So integration of 0 will be 0 only. So the CDF value in this range is 0. Now we will see for 0 to 1 range. Now as we know that our number line is divided in 3 regions by 0 and 1, and now we will be seeing the CDF value in this range. So I need to integrate from minus infinity to y, where y will be lying in the range 0 to 1. So now since y lies between 0 and 1, we can't directly integrate from minus infinity to y. There is a hurdle between minus infinity and y, which is 0. So we will first integrate from minus infinity to 0. Then we will integrate from 0 to y. Now since we know that the PDF value from minus infinity to 0 is 0, so here I will be having 0. And for the reason 0 to 1, the PDF value is 3y squared, so I will put that value here. Now integrating this and putting the limits, we are going to get 3y cube. So for range 0 to 1, the value is 3y cube. Now the third range that we have is from 1 to infinity. Now I will integrate the PDF from minus infinity to y, where y will lie between 1 to infinity. Now since I know that the y lies between 1 to infinity and I can't directly reach from minus infinity to y, there are two hurdles in between minus infinity and y, which is 0 and 1. So first I will come from minus infinity to 0, and then I will go from 0 to 1, and then from 1 to y. So the integration will be like this: minus infinity to 0, 0 to 1, 1 to y. Now we know that the PDF value at minus infinity to 0 is 0, so I will put 0 here. And the PDF value between 0 to 1 was 3y squared, so we will put 3y squared in this range of 0 to 1. Now again for the range 1 to y, the PDF value was equal to 0. So again I will put 0 here. Now the integration of 0 are 0. So here I will be having 0. Here we will integrate this from 3y cube, 3, 0, 1, and this will be 0 again. So finally I will be having 3y cube by 3 with the limits 1 to 0. And now on putting the limits, I am going to get 1 minus 0, which is equal to 1. So the CDF value in the range 1 to infinity, that is y greater than or equal to 1, will be 1. So now using these different values, I can construct my CDF as for y greater than 1, the CDF value is 1, and for range 0 to y, the CDF value that we have got was y cube, and for the range y less than equal to 0, the CDF value was equal to 0. And now you can match this answer with the CDF value that we have taken earlier to check this. So as you can see, the CDF that we got from our answer is same as the CDF with which we have started our answer. Now let us move on to the second question. Now the second question says that the random variable x has the following PDF, where it is given to us for x greater than or equal to 0, the PDF value is this, otherwise it is equal to 0. And in the A part we need to find the value of the constant C, and in the BC part we need to find the probabilities between the different ranges. So let us start the A part. To find the value of the constant C, I can use the property of PDF, which can say that minus infinity to infinity integration of PDF is equal to 1. So for some of you who are not able to digest this property, I want to tell from where this property has come. Now you must note that sum of probabilities of an event is equal to 1. Therefore, integration of minus infinity to infinity, the PDF is equal to 1. This property itself has come from this. Now using this property here, I can write that minus infinity to infinity integration of PDF is equal to 1. Now we know that the PDF in this given table is divided into two regions by the number 0. There are the two reasons. The first one is from minus infinity to 0 and the second one is from 0 to infinity. And we can see that for this reason the PDF value is 0, and for this reason the PDF value is Cx e to the power minus x by 2. Now let us put the PDF value here from minus infinity to 0. The PDF is 0, and from 0 to plus infinity the PDF value is this, and this is equal to 1. So finally this will be equal to 0 and this integration will be equal to 1. Now to solve this integral we need to use the substitution method, and here the substitution that we're going to take is minus x upon 2 is equal to t. This substitution is best here because it will help us to simplify the term in the power of e. Now taking this c out, since this is a constant, and multiplying minus 2 here and dividing minus 2 here, I can get this expression. Now using our substitution of minus x by 2 is equal to t, I can get t multiply e to power minus t by t dx is equal to 1. Now if I want to integrate this, then I need to change dx to dt. To change this, again we can use our substitution, which was minus x by 2 is equal to t. Now if we will differentiate this, then I will get minus dx by 2 is equal to dt, which is equal to dx is equal to minus 2 dt. So putting the value of dx in this expression, I can get minus 2c integration of 0 to infinity t e minus t, it's minus 2 dt is equal to 1. So taking this minus 2 out, I can have 4c 0 to infinity t e minus t dt is equal to 1. So now I can integrate this and put the limits. So to integrate this, we need to use the eyelet rule. Now using this eyelet rule to integrate this, I can proceed. Now it was plus t. I have by mistake taken it as minus t. So I must do it plus t because minus x by 2 was equal to t as according to our substitution. Therefore minus x by 2 was equal to t, so it is plus t, not minus t. So again rewriting my expression, I have will be having 4c e to power minus x by 2. Now simplifying this expression, I can have now putting these limits in this expression, you can get here we will be having 0 because putting infinity here we will be having 1 upon infinity which will be equal to 0. Now putting infinity here you will be having e to power infinity which is equal to infinity, and a finite number upon infinity is equal to 0. So it is 0 minus, putting 0 here we will be having 1 is equal to 1. Now finally the value of c that we have got after solving that is c is equal to 1 by 4. So this is the answer for the A part. Now let us see what were the B and C parts. In the B part, we need to calculate the probability when x lies in the range 0 to 4. Now to solve this, I can use the property of PDF, which is integration of 0 to 4. PDF, give me this probability. Now we can see that in the range 0 to 4, the PDF value was this. So we can integrate this value and put this range. Now we have already integrated this, only we need to change the limits in the previous part A. As we have seen in the previous part, its integration was equal to this. Now I can put the value of c equal to 1 by 4 and put the limits in this range to get our answer. Now similarly for the c part, you can just change the limit here and you can get your required answer. Now you must note that in the integration of -2 to +2, you cross the hurdle which is 0 here, because before 0 and after 0 the value of PDF changes. Before 0 the value of PDF was equal to 0, and after 0 the value of PDF was this. So you need to make the two intervals here, which is -infinity to 0, and the second one is 0 to +infinity. In the interval -infinity to 0, the PDF value was equal to 0. So you will be having 0 here, and here you will be having 0 to 2. This. And again you can use our previous integration to get the required result. Now again here you can put the value of c equal to 1 by 4 and use the limits to get your required answer. Now I hope that all the concepts related to PDF and its properties are clear to you. So see you in the next session.